Hello everyone, I'm Dr. Sivan Singh and currently I am an assistant professor in the Department of Applied Chemistry here at Amity University, Gwalior. And today I am going to discuss something which is very interesting for science students, particularly chemistry students. So whenever we have to solve the structure of any molecule in chemistry, then everybody know like it is one of the most toughest job to determine the structure, the real structure of molecule based on certain data which is available depending upon the type of instruments on which they're working or type of information which we have available. So on the basis of data availability, we can predict or we can derive the real structure of some molecule. So in this particular lecture, I'm going to discuss some critical informations, which are, of course, very important for any chemist. And this lecture will help uh, people to understand the uh, applicability of these concepts. So, of course, with this brief introduction, I would like to start my lecture. All right. So, if we talk about the topic of today's lecture, so we are going to discuss about the determination of empirical formula, molecular formula, and structure formula for the compounds. So these three are interconnected. First, we have to sort out the real empirical formula, and depending upon the molecular weight and the data of empirical formula, we can figure out the molecular formula. And depending upon the molecular formula and our data availability, like if we have some spectroscopic data, like the NMR data, mass data, IR data, or UV data, then we can figure out the structure formula. So let's see. Right. So already I have discussed the content. So we have to go through three basic fundamentals: empirical, molecular, and structure formula. So with this particular, concept, like you talk about the structure formula of benzene. So everybody know it is the structure formula of benzene. It has single bond and double bond in the alternate fashion. So if you talk about the molecular formula of this benzene, then people know, okay, this is C6H6. But when it comes to empirical formula of benzene, it is CH. So with this, simplest example, we can figure out the difference between empirical, molecular, and structure formula. Now we'll be discussing all these three one by one. So, what do you mean by empirical formula? The first question which comes to our mind whenever we think about the empirical formula. So, like it is written here, we can easily understand. Like empirical formula is the simplest formula of any compound. Simplest formula in the terms of stoichiometric amount of number of atoms which are present in compound. So we also say like, okay, this could be the smallest whole number ratio. This is the smallest whole number ratio of atom, but it does not necessarily represent the arrangement of atoms in the actual molecule. That is also you have to keep in mind. As we have discussed previously, like for benzene, it is C6H6 is the molecular formula, but when it comes to empirical formula, it is CH. Similarly, everybody know like the formula of hydrogen peroxide is H2O2. This is the molecular formula of hydrogen peroxide. But if we have to figure out the smallest whole number ratio of atom, then of course we have to divide these digits by the 2. Then this HO will be arrived. So this will be the empirical formula of hydrogen peroxide. So this is how we can understand. Just for the practice, I have added this question, like if we have this molecule like C12H4Cl4O2, this is the formula of dioxin, which is a very powerful poison. And if I'm talking about what could be the empirical formula of this molecule, then we have to figure out what is the smallest stoichiometric amount of atom which is present. And here we have it is 2. So we have to divide all these stoichiometric atoms which are present in the molecule by 2, and then we can find out the empirical formula of the molecule. So for this case particularly, we can figure out that C6H2, Cl2 and O is the empirical formula of this dioxin. Similarly, if I ask you like what could be the possible empirical formula of this case is, so in this case, the smallest number is 2. So we will simply divide all digits with 2. So we'll have the C2, H3, 8, and then N. Similarly, for CCl4, the smallest number is 1. So for CCl4, the empirical formula and molecular formula will remain same. For C4H10, of course, we can divide this equation by 2. So we can have C2H5. So these are the empirical formula of this, molecules, right? So the question is how we can determine this empirical formula. So for determination of this empirical formula, we have some, roadmap. Like we have to know the atomic mass of atoms which are given in the question. Then we have to divide by the molecular mass of this particular atom. Similarly, we have to divide the molecular mass of X. Then we find the number of moles. If we have number of moles, then we have to divide the smallest number of moles with each one. Then we will have some A to X ratio, and this then we have to convert this into a whole number. If they are fractional number, it could be possible like this A to X ratio can be fractional. Then we have to convert this fractional number into whole number, and then it gives rise to empirical formula. So that is how we can simply determine the empirical formula of molecules. So example, like we have this question, we have 1.7 gram of carbon, we have 0.287 gram of hydrogen. Then we have to find out the empirical formula. Then we know that the mass of carbon is 12. So we have to divide this weight by molecular weight. So 112. The atomic weight of hydrogen is 1. So this is 1 by 1. So we will have this digits 0.0974, and then we have 0.284 for this hydrogen. So in determination of empirical formula, we have to take digits up to 3 significant figures. And we know that the smallest number among these two is this one. So we will, divide all these two with this smallest number. So we have this equation like CH3. So CH3 will be the molecular formula for this particular example, right? Similarly, if you talk about the empirical formula of other molecules, like if we have 5.31 gram of chlorine and 8.40 gram of oxygen, then similarly, you have to apply the same concept. We know the molecular formula of chlorine is 35.6 and oxygen is 8. Then first we have to figure out the number of moles. Once we have number of moles, then we will simply divide this number of moles with the smallest number. And we know among these two, this is the smaller number as compared to 0.5. So we will get this ClO 3.5. Now, this cannot be the empirical formula because this is a fractional number. 3.5 is a fractional number. So in order to convert this into whole number, we simply multiply these numbers into 2. So we can have Cl2O7 as the empirical formula for this particular case. Right. So we talked about these stuffs already. You can pause the video and you can go through the this reading part, right? Similarly, if I am asking like if you have a sample having 0.130 gram of nitrogen and 0.370 gram of oxygen, then what could be the empirical formula? The answer is same. We have to follow the same process. We have the protocol how we have to move forward, and accordingly we can figure out that it is N2O4. That is for your practice, right? If even percentage is given, like if the weight is not given in grams, if it is percentage also, then we have to also calculate the number of moles first, and then we have to proceed in the similar fashion. So if we have this type of question, we will simply figure out like, okay, we know the atomic mass, then we can figure out the number of molecules. Then we have on the basis of these two, we have to find out what is the smallest value. If we have this smallest value, we will divide this smallest value with these 3, and then we'll have this value, and this will be our empirical formula. So similar question. We have another question like we have if we have iron 69.9 gram by mass, and what could be the empirical formula? Then we know this is iron oxide. So iron and oxygen is present here. We know the atomic mass of iron and oxygen. We can find out the smallest number, and then we can simply divide this number, and we can find out the integer value. So it is Fe2O3. All right. For practice, I have added some other question. You can pause it and you can solve the question just for better understanding, right? Now let's talk about the molecular formula. So how we can calculate this molecular formula? So most common instrument which is available for the determination of this molecular mass is mass spectrometer. So on the basis of mass spectrometer, we can find out the molecular mass of any compound. So it represents all the atoms, the sum of masses of all the atoms which is present in the molecule, right? How we can calculate it? So if we have molecular mass of any compound and we know the empirical formula mass. So we know the molecular mass, right? The molecular mass is the absolute, like the total number of mass of atoms which are present in a molecule. But when we talk about the empirical formula mass, so this is the mass of compound having some empirical formula. So suppose we have any molecule having some empirical formula. So we have to find out the total mass of that particular empirical formula, and that is called empirical formula mass. So if we divide this molecular mass of a compound with empirical formula mass, then we can find out the number of n. We say that is formula units or molecule. So what you have to do at the end, like we have to multiply this n with the empirical formula. Suppose we have the empirical formula AXBY, and on the basis of molecular formula, on the basis of molecular weight and empirical formula, we have value n. So we have to simply multiply this AXBY with n, and this will be our molecular formula. So suppose, let me explain this particular, content by this relevant example. We have CH2O. This is the empirical formula of a molecule. And if you talk about the mass, then of course this will be 30 AMU. This will be the molecular formula mass of this compound, because carbon has atomic mass 12, hydrogen has 1, oxygen has 16. So if we add these, then we will have 30, right? And by mass spectrometer, suppose we have figured out like the atomic mass of the compound is 180 m. Then we have to simply divide 180 with this empirical formula mass, which is 30. Then we will have value 6. We know that empirical formula CH2O. Then we have to multiply this CH2O with 6. Then we will be, find out the like we will have this value say 6H12O6, which will be the molecular formula of the compound. Right. Similarly, we have a variety of questions we can have, but the answer will follow the similar pattern. For practice, I have added this particular slide. You can pause it and you can go through this PPT. You can solve it. It's it's quite easy to understand. Right. We have one similar question for the practice. Like we have, what is the molecular formula of a compound with a percentage composition of 49.47% carbon? We have 5.201% hydrogen, 28.84% nitrogen, and 16.48% oxygen. So this is the composition, like we have carbon, hydrogen, nitrogen, and oxygen. The molecular mass is also given, that is 194.2 m. So as we have mentioned already, like first we have to find out the smallest value. Like first we have to find out the number of moles. On the basis of number of moles, we have to find out the smallest value. So this is the smallest value. We will divide all these equations with this smallest value. Then we will have this simple ratio. And if we figure out the possible integer values, which is very close to this, so it will be 4251. And this will be our empirical formula. And this, on the basis of this, we can find out the empirical formula mass. But since the molecular mass is 194, so on the basis of this empirical formula mass, we can simply divide this 194.2 upon this 97. Then we will find that this is 2. So we'll multiply all these values with 2. And accordingly, we will find the answer, like it is C8H10N4O2 is the molecular formula of this compound. All right. So now we have figured out like how we can calculate the empirical formula and molecular formula of compound. Now, depending upon the availability of some other data, we can find out the structure formula. So one theoretical formula which we can use to determine the structure formula, we say is double bond equivalent. DB, double bond equivalent. So with the help of double bond equivalent, we can find out the number of unsaturation or number of ring present in a molecule. And ultimately, it will help you to find out the degree of unsaturation or number of rings in the molecule. So what it represent? It represents simple like okay degree of unsaturation or number of rings or number of whether the molecule is saturated or unsaturated. So we can figure out how we can calculate this dBE. We have to find out the total number of carbon which is present in the molecule. So we will add this carbon with 1, C plus 1, minus then this represents number of hydrogen, this is the number of halogen X, and is number of nitrogen divided by 2. So if you apply this formula, suppose, and we are having dB value, suppose we have dB 0. So what does it indicate? It indicates that there is no double bond or there is no ring in the molecule. If dB is 1, then possibility is that the molecule may have one double bond or it may have one ring. If dB is 2, it means either the molecule has two double bond or two ring, or it has one double bond and one ring, or it could be, like possibilities like it may have one triple bond, because one triple bond has two pi bonds. So we can say like it has one double bond or two double bond also. Okay. So now comes to if dB is 3 or more than 3, then we can say if it is 3, then either it has three ring, it has two double bond and one ring. So which is if we add this 2 and 1, then we have 3. Or it could be one double bond or two ring, or it could be one triple bond plus one double bond, or it can have three rings. So we have a lot of possibilities depending upon this dB value, right? So how we can figure out how we can apply this concept? So to understand this, whether which functionality is present. So like I mentioned, if dB is 0, it means the molecule can be saturated molecule. It will be definitely alkane. If the value of double bond equivalent is 1, then the molecule, the functionality or the core structure may contain alkene or cycloalkane. Alkene has one double bond, one pi bond. Cycloalkane has one ring. So that is equal to 1, as I have discussed previously. If dB is 2, it means it can be alkyne, it can be cycloalkene, or it can be diene. Alkyne means it has two double bond. Cycloalkene means one double bond and it has one ring. So if we add one double bond and one ring, so it will be equal to 2. If we talk about diene, so diene has two double bond. So we can say, okay, this is following this dB pattern. Right. So like this particular case 1 is applicable when the molecule has only carbon and hydrogen. Suppose in our molecular formula, the compound has carbon, hydrogen, and only one oxygen. Then what could be the possible molecule? What could be the possible framework in the molecule? So if dB is 0, then we can say the molecule can be alcohol or ether. So they are saturated alcohol, of course, because there is no double bond, there is no ring even. If the dB value is 1, then it can be aldehyde or ketone because they have one double bond, or it can be unsaturated alcohol, means there must be one double bond in the in the core structure of the molecule. In the case 3, if we talk about the molecule has one carbon, hydrogen, and two oxygen. So if we solve the question, we have this molecular formula and we have figured out that dB is 0, then we can say this is the saturated diol, because diol has two oxygen. So we can easily find out. If dB value is 1, then of course we can say it could be acid or ester, because they have one pi bond in carboxylic acid or even in ester. And in acid and ester, we already know like they have two oxygen atom apart from carbon and hydrogen. So they can fall into this category, right? If you say like in our molecular formula, we have carbon, hydrogen, and we have nitrogen atom. And on the basis of this molecular formula, we have calculated that the dB value is 0. Then we can say like it could be amine. Amine can be primary amine, secondary amine, or tertiary amine, but they must be saturated amine because there is no double bond in the molecule if dB is 0. If dB is 2, then it can be cyanide or isocyanide because they have two double bonds. We already know. Okay, case 5, if you say like if a molecule has carbon, hydrogen, oxygen, and it has one nitrogen also. So what could be the possible, framework in the molecule? So based on this molecular, formula, we can find out if dB is value 0, then it could be amino alcohol or amino ether. If the dB value is 1, then we say like, okay, this is amide. If the dB value is more than 4, 4 or more than 4, then we can say that one benzene ring present in the molecule, because we already know, like, if there is a benzene ring, so benzene means we have one ring here and we have three double bond. So if we add this data, three double bond plus one ring, that is equal to 4. If it's more than 4, then maybe here some ring or something else is present. So depending upon the availability of data, we can predict the structure. Another possibility that dB may be negative at some point, then in that case we say like the compound is organic salt. All right. So let's apply this concept and find out the degree of unsaturation in molecules. So if we have one example, like we have benzene, and we have to find out the degree of unsaturation, then we already know, like, okay, the benzene, like, this is the structure formula of benzene. And how it comes, like, we know that dB is equal to, for benzene, C plus 1. C, total number of carbon is 6, so it will be like 6 plus 1 minus total number of hydrogen is 6, halogen 0, nitrogen 0, 6 by 2. So we know, like, if we solve this equation for benzene, then the value of dB will be, it will be 4. 7 minus 3, so it will be 4. 4 means it has one ring plus 3 double bond. So that is how we can easily solve the structure formula of compound. For ethylene, we already know, like, okay, the dB for ethylene will be equal to 2 plus 1. So right, we can write 3 minus 4 divided by 2, because there is no halogen, there is no hydrogen. So if we calculate is 3 minus 2, it will be 1. So we already know, like, the structure of ethylene, it is CH2, CH2. So it has one double bond which is present in the ethylene. Similarly, for acetylene, if we apply this concept, so it will be 2 plus 1 means 3 minus 2 by 2. So the value of dBe will be 1. And 1 sorry, it will be 3 minus 1, so it will be 2. It means there will be 2 pi bond which is present in the acetylene. Similarly, for cyclobutadiene, so if you know the structure of cyclobutadiene, so this is cyclobutane, and butadiene means this is the structure of cyclobutadiene. And if you write the molecular formula of this compound, so it will be like C4H8. Sorry, not it. 1, 2, 3, 4. So it will be C4H4. For C4H4, if you apply this dB concepts, and so it will be 5 minus 4 by 2, it will be 2. So value is 3. 3 means it has one ring and it has 2 pi bonds. So overall, if we add this number of rings plus number of double bonds, so value will be 3. So which is actually showing that the molecular formula, or more this structure formula of this compound, is corresponding to the molecular formula, and this dB concept is equally applicable for this particular case also. For cyclopentadiene, we know, like, okay, cyclopentadiene structure is like this. So from here we can figure out, for cyclopentadiene the molecular weight will be like C5 and H 1, 2, 3, 4 hydrogen, and 5, 6 hydrogen, 6 hydrogen. So if we calculate the dBe, then 5 plus 1, 6 minus 6 by 2, 3. So the value will be 3. So if you apply this particular dB concept on this cyclopentadiene, then we can find out we have 2 double bond plus 1 ring. So it is also following the concept of this dB. It is showing the pattern which should be there. If it has carbon, hydrogen, number of rings are there. For naphthalene, we know the structure of naphthalene already. So these are the examples which I'm discussing are actually already known molecules. For understanding, you can apply this concept for any particular molecule if you have molecular weight or some other data. So the molecular formula of this naphthalene is C6 plus 4, C10. Hydrogen, number of hydrogen is 1, 2, 3, 4, 5, 6, 7, 8. Now apply this dB concept, so it will be like 11 minus 8 by 2, 4. So the value will be 4, 11, 7. So we have 3 double bond and 2 double bond, 3, 2, 5, one ring here and one second ring is here. So total number of dBe or degree of concentration or double bond equivalent will be 7. So this particular formula also justified that naphthalene formula is is also showing the pattern of this dB concept. For cyclohexane, let's talk about the last one. Cyclohexane, we already know this is the formula of cyclohexane. The molecular formula of the cyclohexane is C6 and H12. If you apply the dB concept, then it will be 7 minus 6, because 6 plus 1, 12 by 2. So 7 minus 6 means 1. It means degree of concentration or dB value will be only 1, which is reflected like we have only one ring in the cyclohexane. So this is how we can find out the real structure of cyclohexane, and we can cross check it with the concept which we have discussed earlier. Right. Similarly, if I'm giving you some questions for practice, like determine the empirical formula of compounds with the following percentage composition. We have carbon, we have sulfur. This is for the practice. We have carbon, we have hydrogen, we have oxygen. And on the basis of this amount, if you have to predict or you have to figure out the empirical formula of the molecule, then you can solve like it is CS2 and CS2O. That is for your practice purpose. Another question for a practice I'm giving is like determine the empirical formula, molecular formula of triacetyl asbestos. This has the following composition. It has 28.03% magnesium, it has 21.60% silicon, 1.16% hydrogen, and 49.2% oxygen. So on the basis of this given data, we can find out the empirical formula. The molecular formula of this compound is already given, so we can find out the N value, and then we can find out on the basis of this N value, we can find out the molecular formula of compound as well. So the answer is given here, and you can solve it. This is for your practice only, right? So this is it. I believe like I have explained the concept of empirical formula, molecular formula, and structure formula. So with the help of this PPT, with the help of this particular lecture, if you read it and if you solve the questions which are given here for your practice purpose, I'm sure like you can easily understand the concept of empirical formula, molecular formula, and structure formula. You can also figure out the different types of questions and different types of problems which is there in the textbook at different level. So as far as this concept is concerned, this concept is mainly used at a very fundamental level like BSc or 11th, 12th level. So, but I believe like it has a lot of applications even in the research field also. If you go to research, if you're doing some research and you are going to predict the structure of the compound, then you can also use these tools and techniques. Ultimately, they will help you to solve the structure of a compound, and which is very, very crucial for any organic chemist across the globe. So thank you very much. I hope this video will provide some information to science students. Thank you so much.